Alright, this video is about characteristics of sound. For the most part, this video is just informational, just some stuff that might interest you, just some numbers that might be, kind of cool things to know. Um, First off, though, I'm going to start off with something that you will need to understand, and that's that the speed of sound is different in different materials. Sound traveling through air and sound traveling through water and sound traveling through a solid material all travel at different rates. A common one that we will use in actual problems and that you also worked with in lab on our last class period is the speed of sound in air. If you look at it, in air, at 0 degrees Celsius, the speed of sound should be 331 meters per second. At 20 degrees Celsius, it should be at 343 meters per second. These are pretty common values that you might have to use in problems. If you ever need to solve for the velocity of sound in air at different temperatures, this is the equation that you should be familiar with. I would pretty much try to commit it to memory. The velocity in air would be 331 plus 0.6 times the temperature. Don't forget that the temperature needs to be in Celsius. Just some stuff that might be kind of interesting for you. Loudness, the louder something is, it's determined by the intensity of the particular wave. And we solve for intensity by doing power per unit area. Okay. The pitch of sound is determined by the frequency. The higher the pitch, the higher the frequency. Audible range, things that the human ear can actually detect, range anywhere from 20 hertz to 20,000 kilohertz. This, at least for me, is important when you buy, say, some speakers for your home theater system. You want speakers that have a nice range for audible signals, okay? You don't want to buy some, high-end speakers that don't have a very nice audible range. So sometimes it's nice to actually understand what the range is, okay? Things that are called ultrasonic are things that are above our audible range of 20,000 kilohertz. Just for fun facts here, dogs can generally hear up to 50,000 kilohertz. That's why we have dog whistles, because they can hear it and we can't. Bats can hear up to 100,000 kilohertz, so they have very sensitive hearing. Things that are below our audible range are called infrasonic, things that are below 20 hertz. Something that is useful for us is talking about the sound level. Okay, just so that you're aware, intensities that the human ear can withstand usually range from something to 10 to the negative 12 watts per meter squared to about 1 watts per meter squared. This particular value right here is known as the threshold of hearing. I'm sorry, this one right here is the threshold of hearing. If you go below this, chances are you're not going to be able to hear it. If you go above this, chances are it's going to be very, very painful to you. Okay. One thing to understand about intensities, in order for something to seem like it's twice as loud, it actually has to be 10 times as intense. Therefore, if you're talking about intensities, something that is times 10 to the negative second is only twice as loud as something that is 10 to the negative third. And then something that's 10 to the negative third is only twice as loud as something is 10 to the negative fourth. Now, there is an equation that goes ahead and solves for these, and AP students, you're going to have to be aware of this. IB, you'll have to do it to complete the homework. I haven't seen much of it on IB questions, but something called the sound level, which gets this symbol right here, big beta, measured in decibels. So you've heard of things like decibel meters. If you wanted to measure the sound level of something, it's 10 log of the intensity divided by the threshold of hearing intensity, which is 1.0 times 10 to the negative 12th. This is the basic equation. It is logarithmic. Why? Because in order to be double as loud, it was a factor of 10. Okay. a nice, easy, or not necessarily easy, but a helpful little ratio for you. If we rearrange this equation to try to get log out of there, you end up with the intensity over the threshold of hearing is equal to 10 raised to the sound level divided by 10. This particular equation right here can be helpful when you complete your homework. Okay?